Yeah, any question? Yeah, have you write the answers?
Sir, I have a question.
Yeah, please.
So the EMF will stay constant at all time in the circuit?
EMF is, yeah, EMF is definitely constant because
Okay,
EMF is of the battery. So that's why EMF is constant.
okay, sir.
So can somebody tell me first point? First point.
As the intensity increases,
Mhm.
the resistance will decrease.
Okay, let me write that. LDR resistance as the light intensity increases, the LDR resistance decreases. So this is our first point. Yeah, second point.
The resistance decreases because of more conduction of electrons.
So more conduction of electrons. That's good. Well done. Okay. Third point.
When the resistance decreases, the power loss increases.
Okay. How you can say that power loss increases?
P is equals to V square upon R.
That's good. So give the formula. Okay. So because the net EMF is constant, so then the resistance decreases. Decreases. Okay. Resistance decreases. Power loss increases. So these are considered to be 2 points, okay? 3 and 4. Yeah, fifth point. Fifth point. Yeah, Amna, fifth point.
I'm not sure, sir.
Greater current will flow also.
Yes.
Okay. Can somebody tell me last point? Last point. Because we need 6 points, okay?
The voltage stays constant.
So net EMF or potential difference remains constant. Okay. Now let's see the marking scheme, okay? Let's see the marking scheme now. Have you write the points? Have you write?
Yes.
Okay, now let's see the marking scheme. Okay, the marking scheme telling us that first point. Okay, that's not. Okay, let me. So the first point, resistance of LDR decreases. So have you write that, all of you, have you write that point, first point? So increases the number of induction of electron. So the resistance of circuit decreases. This is the point you have missed. So total resistance decreases. It's fine.
Yes.
So this is important point. Now the net current, greater net current in the circuit, EMF is the same that you have written. And I think Aisha has told us that P is equal to V square over R. Yeah, Aisha.
Yes, sir.
Okay, and the power loss is less. So how many points? 1, 2, 3, 4, 5, 6. 6 points are there. Which point we have missed only? Which point we
The
have missed?
total resistance.
Exactly. So remember that we have written the last point that the total EMF is same. Don't write that point, okay? Total resistance decreases. Total resistance decreases. Or the net. Have you understand that point? What do you mean by total resistance decreases?
Yes.
Okay. And you will allow, if you write this point, you will allow that, okay? That total voltage will remain the same. It means you can got 6 marks. If we have write that total voltage is remain the same, so it means so we can get a total mark, okay? It's fine now. Yeah.
Yes.
Okay. Yeah. Any question?
No, sir.
Okay. Okay. Let's go to the another part. Yeah, that's the part you are facing difficulty. Yeah.
Yes.
Okay. Who have done the first part? Aisha, have you done the first part?
I just wrote 1 point.
Okay, you wrote 1 point. And what is 1 point that?
When the transducer emits the pulse, it hits
Mhm.
the crack and it reflects and returns back.
Which cracks? Which cracks? A or B? You are talking about A or B? Yeah, Aisha.
Crack A.
Okay, you are talking about crack A. Yeah, Amna. You have right that?
No, sir.
Okay. And what about Hafsa? You?
No,
Okay, let's see the question. What is question? The question is that translucent, this transducent, when through the pulse came to the crack A. Okay. Now, when this is came to the crack A, this is the question arise that the return pulse from the each crack explain why the returning pulse from the B. So means the sum of the pulse will return back and some of the pulse will pass through it. And then it will be reflected back from the B. And why the sum of the pulse is passed through the A and why the sum of the pulse cannot pass through the B because of the difference of different nature of material, nature of metal, sorry, because of the different nature of metal. Yeah. Have you understand it?
Yes.
Can I repeat the points? What is first point?
Yes.
What is first point? The first point is that the pulse, some pulse passes through crack A and some of reflected. Number 2 point. The pulse reflected from crack B. And the third point, due to different metal nature of crack B. It's fine. So these are the 3 points. Kindly wrote the points, okay? Then we will check from the marking scheme. Yeah. Have you wrote it?
I'm still writing.
Okay. Yeah, Amna, any question?
Sir, for the metal nature, can we also not mention the difference between the density? How thick the
No,
no?
no. Yeah, we can mention it. There is a difference between the density of the metal. You can mention it, but as you mentioned, there is a different metal nature. So all the properties are coming inside in it. So you can, if you
Okay.
want to mention the difference density, you can mention it. Yeah. Yeah, it will be very good.
Okay.
Yeah.
Because in school, our teacher told us that if it passes through a crack, it's because of the density.
Yeah, that's good. Yeah, that's why I said it's good. You have to mention it. It's fine. Different metal density. So that's very
Okay,
good.
sir.
Density nature. That's good. That's good. Yeah. Any other point?
No, sir.
Have you completed Aisha and Hafsa?
Yes.
Yes.
Okay. Okay. Let's see the marking scheme. Okay. Have you seen the points? The sum of the pulse passing and reflected from Craig 1, sum of the pulse reflected from Craig B, and because of density material medium of the cracks. Yeah, is the Amna says if we mention the density metal or material or medium of the crack, so it will be better. Okay, it's fine. Yeah.
Yes.
Okay, let's go to the next part. Next part. What they have sent in next part? Yeah. Oh, the next part. Kindly remember that. Okay, they says calculate the detect the whether pulse is returned A, B, and C. Okay, which formula you have to use? Kindly see the formula. Okay, this is your transducer, and this is the Craig. For example, when the pulse comes, its covered distance D and its reflect back again its covered distance G. So whenever they says calculate the time, so the formula will be equal to 2D divided by T. It's fine now. Yeah. Or you can write T is equal to 2D divided by V. Have you understand the formula?
Yes.
Yeah, Aisha, Afza, have you understand the
Yes.
formula? So because that is come, the pulse is comes and return back. So that's why it covered 2D distance. Okay. So now can you calculate the time? Oh, sorry, what we have to calculate? Detect whether the pulse has returned from the crack A. So we have to calculate the distance. Sorry, we have to calculate the distance. Okay. So distance is VT divided by 2. Now, can you calculate the distance now? V is given to you, that is 5900. T is given to you, that is 1.4 into 10 raised to power minus 5 and divided by 2. What you got? Yeah, what you get?
0.0413.
Okay, 0.0413 meter, or that will be 4.13 centimeter. This is your D. Now, what you will do, you will take the ruler and measure the distance between these cracks, okay? Pulse and the cracks. Now, have you understand it? What do you think?
Yes.
Which distance is 4.1? That is crack 1. This distance is 4.1. This is 4.1 or this is 4.1. What do you think? Any guess?
The first
Aisha?
one?
The first one. Okay. So who says Aisha?
Yes.
That is your guess or you have measured?
I didn't measure.
Okay, you didn't measured. Hafza, what about you? What is your guess? Yeah, Hafsa. But yeah, Hafsa. Yeah, Hafsa.
Just a minute, sir. I'm measuring it.
Okay, okay, that's good. And what about you, Amna?
Sir?
So I measured it and I got crack is 4 centimeters
Okay,
approximate.
okay, okay. Yeah, Hafsa. Hello. Yeah, anyone?
Yes, sir, I got it as 4 centimeters.
Okay, so it is crack A. Okay, it is crack A. Let's see from the marking scheme. Okay. Yeah, it's a crack A. 0.041 or 4.1 centimeter, and it's a crack A. Okay, that's fine. Now, in last part, explain why the ultrasound used to reflect the metal surface usually has a frequency of microhertz rather than the kilohertz. Yeah, Aisha, you will answer the question. Why not we use the why not we using the kilohertz? Why using megahertz? Yeah,
Because frequency is inversely proportional to wavelength. So if frequency increases, the wavelength it decreases. So the resolution of the image will also
okay,
increase.
that's good. That's good. Can you repeat the word so I can write it in 2 points? Yeah, can you repeat it again?
Frequency is inversely proportional to wavelength.
Okay,
So if frequency increases, wavelength decreases.
that's fine. So,
The resolution of the image will increase.
okay, resolution of image increases or decreases?
Mm, Increases.
Okay, do you think increases? Okay, yeah, Amna, what do you think?
Yeah, the resolution increases, the picture will be more clearer. So you have to
Okay,
use mega than
okay,
kilo.
okay, okay, that's good. And Hafsa, have you done that question?
No, sir.
Okay, let's see the marking scheme. So this says high frequency and means low wavelength. So that's you got the point. And next point, what they have written. Aisha, can you read the next point? What they have written?
Therefore, greater level of detail possible.
Exactly. It means on the basis of this first point, you will give a proper detail as the Aisha gives us that the resolution is going to increase. So that's why we using the megahertz. Okay, that's fine. So your second point must be supporting first point. Okay, it's fine now. Yeah. Okay, Ji. Coming toward the question number 16. Yeah. Read the question in the quick way, okay? Read the question in the quick way. Now find the answer. Minimum potential for which the light headlights well emitted. What we will do? Any one of you. So we will take the best fit line first. Okay? We will take the best fit line first. Do you think that is a correct best fit line?
No, sir.
Okay, let me write it again. No, that's not also correct. Yeah, now it is correct. Okay. Passing from every point equally, equal distance. It's fine now. It's approximately,
Yes.
okay, let me draw it again so that now it's fine. Now can you find the power? Yeah, Hafsa, can you tell me which formula we will use for the power? Yeah, Hafsa. Can you tell me which formula we will use for the power?
V equals to IV.
Oh, that's good. V is equal to IV. So can you calculate it now? I'm making the points for you. So kindly calculate it, okay? Yeah, now calculate it. I think my
35.1.
okay, 35.1. Who got the 35.1 first? Amna, you?
Yes.
Okay. What about Aisha, you? Yeah, Aisha.
Um, I got 35.1.
Okay, that's fine. Aisha, can you tell me why we have taken best fit line? Why we have taken the best fit line? We cannot uh, find the power without best fit line. What do you think?
The points are the answer will be more accurate.
Exactly. So the best fit line is taken because your answer will be more accurate. Okay, so that's why we take the best fit line. Okay, let's check the marking scheme. What will be the answer? Okay, that's good. 35.1. 35.1 is the correct answer. Corresponding value from the best fit line. Okay. So it is this answer is depend on your best fit line. Okay. This answer is depends on your best fit line. It's fine. Okay. Yeah.
Yes.
Have you noted that point, all of you?
Mm, Yes.
Okay. 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 Let's go to the next question. Yeah. Now answer this question quickly. Amna, you will answer the question. Yeah, Amna.
So if it's the battery is 12 volts, so if it's connected in a parallel circuit, so the voltage will remain same 12, but if it's in series, will be divided, so it's gonna be 6. So so higher the voltage, more power it dissipates, so it will produce more light or it will be more brighter.
Okay, the first point is that in parallel, the voltage is same. In series, voltage is divided. It's fine. So that is 12, that is 6. Second point, yeah. Second point is that in parallel, brightness is same. That's fine.
Yes.
And in series, yeah.
In series, it will be lower
Okay, just 1 minute, okay?
than
Yeah.
parallel.
Yeah, just
Yes.
1 minute, okay? Okay, sorry for that. Okay, sorry for that. Have you write the points? Have you write the points?
Yes.
Okay, sorry for that. That's just okay. Let's check the points. So as Amna told us that is 12 volt, 6 volt. The brightness is more in parallel. In series, the brightness is come. And have you missed the last point, Amna? Amna,
Yes.
can you read the last point?
In parallel, if one headlight breaks or fails, the other one remains on, or in series, if one headlight breaks, the other one goes out.
No. Have you understand that?
Yes.
Okay. Have you understand Hafsa and Aisha? Hafsa and Aisha, have you understand that point?
Yes, sir.
So can you tell me, Aisha, that your house lighting is in series or in parallel? Your house
Um,
lighting. Keep in mind in the last point, okay? Keep the in mind in that the last point.
Is it in series?
It's in parallel. Remember that the housing wire is in parallel. For example, one bulb is going to out, it's failed, it's break. Your all bulbs are working continuity, okay? With continuity. It's fine. So that's is parallel connection. It's not series connection, okay?
Okay.
Okay, so remember that, okay? Yeah, last question. Hafsa, last part. It's last part? No, it's the second last part. Yeah, Hafsa. So I will do you. So first of all, they says when the connected voltage in the battery is 12 volt, the combination of two resistance is parallel. 1/4 of the combination of resistance two in series. So you have to verify this statement, okay? And you can use the graph, okay? Remember that now. Remember that when the two bulbs, two resistance are in parallel, they have the same voltage. And for the 12 volt, what is the current? Yeah, can you take the current from the graph? What is the current in the graph? Yeah,
It's 4.6, I think.
4.6. Okay, let's take 4.6. Okay, let's take 4.6. And can you tell me for the 6 volt, what will be the current?
It's 3.3.
It's 3.3. Okay, remember the values. Okay, now we coming back to the questions. Remember the values. Okay. Now, what is the question? The question is that when there is the resistance for the parallel, that is 12 volt divided by 4.5, what is the current now? What is the resistance now? Yeah,
2.6.
and calculate the resistance for this.
One point eight.
Sorry, 1.8. Now you will take the parallel resistance. This is parallel. 1 over R is 1 over 3.6 plus 1 over 3.6. And then for the series, R is equal to R plus R. That will be equal to 1.8 plus 1.8. Yeah, what you get the answer? Here you get 3.6 and here you get R is equal to 3.6 divided by 2. So R will be equal to, that is 1.8. Have you find the answer?
Sir, the first value 12 divided by 4.5, it's 2.6.
Okay, so 2.6. So I am wrong. So somebody told me, I thought it is, so 2.6. So it come out to be 1.3. 1.3 and 3.6 divided by 1.3 is come out to be 4, I think. No, it's come out to be
2.7.
2.7. So it is approximately 1/4. It is approximately 1/4. Okay. Yeah. So, okay, let's see the marking scheme. Yeah. Have you seen the marking scheme? That is 3.6, 1.3, and that's the ratio of 2.9. I have done some mistake in the calculation, but at the end I got the answer. Yeah. Have you understand it?
Yes.
Okay.